Hey everyone, I'm Kaitlyn Barnard.
And I'm Victor Gamov.
In this series, we chat with software developers and technology leaders to tackle your biggest API connectivity challenges.
Stay tuned to this episode for tools, tactics, strategies that will help you to take your distributed architectures to the next level. Let's begin. And today I'm super delighted to welcome Chinmay Gaikwad from Epsagon to be my guest today. Chinmay, welcome.
Thanks, Victor. It's good to be here.
And can you talk a little bit about yourself? Like what you do, where you're coming from, what's the Epsagon is famous for?
Yeah, sure. So I basically come from a software development background. I started off my career at Intel as a software developer. I was there for a few years, then moved around roles. I jumped from software engineering to application platform engineering to technical marketing engineering. And then I also did a bit of product marketing. And now I'm a technical evangelist here at Epsagon. I'm based out of New York. Love the city. I think it's one of the best cities in the world.
I live also close to New York. And when people asking where I'm from, I usually say I'm from New York, even though I technically live in New Jersey, but kind of line from my view. So I can call myself also kind of New Yorker. Some people might disagree, but haters gonna hate. New York state of mind.
Yeah. So essentially, Epsagon is an observability platform, and we help monitor applications running in Kubernetes and serverless environments. And Epsagon started as a distributed tracing-based observability platform, and we can talk more about that as we go further along. But that's what Epsagon does essentially.
That's actually pretty cool, and I think these days the observability and health of production systems is becoming more important when we're talking with engineers, we're talking with the builders, people who build the systems, and want to make sure that the system stays up 24/7 and no one gets paged in the middle of the night and things like that. Let's talk a little bit about these challenges. So I already call out some of the things that I remember from my years when I was a consultant, when I work with some of the teams where we provided some production support. And that time it was just something different. They only call me as a developer when something was really bad, because there was a development team. We developed the code. We throw this over the fence, and the people need to support this. And we didn't care much about what they're going to be using for monitoring, how they're going to be alerted, and who will be on call, and all these kind of things. And over the last, couple of years, maybe like the last 10 years or so, this situation has changed. How you see this over the years in your career?
That's a great question. So over the last 10 years, I have seen two kinds of changes. The first one being on the architecture side of things. So essentially, what I mean by that is earlier we had monolithic-based applications. Now we have microservices-based applications. So essentially, what that means is we have smaller applications which are easy to manage, scale, and deploy. So that's a huge shift that I've seen over the last 10 years. And the other shift that I've seen is developers versus a DevOps culture. And as you mentioned, just developing the code and throwing it over was kind of a thing back then. But these days, you are responsible for your own code. You're responsible for monitoring the health of your own code. So the DevOps culture has clearly integrated in most of the companies these days. So those, I think, are the two major shifts that I've seen over the last 10 years.
As many listeners know, that Kong is a cloud connectivity company, and we really, truly care about the connecting the applications through APIs, through all, sorts of things, how distributed systems are connected. So that's why for us, it's also important topic, how we can, provide this like connectivity, like electricity or water or even air for modern digital enterprises. And the part of observability and monitoring to make sure that things are going smoothly, it's also important for us, for us as a company. So let's talk a little bit about Epsagon and what do you do there, and what's the product and how it helps to solve the problems that we just discussed, like these challenges that we kind of sum up a little bit.
So traditional observability platforms were focused on monitoring monolithic-based applications. What I mean by that is the logic of the code was within an application itself. So it was kind of easier to moderate or monitor the applications itself. And they were also focused on infrastructure because back then, infrastructure was very varied. So we had virtual machines, we had dedicated servers, we had on-premises, we had in the cloud. So infrastructure was kind of varied. But these days, essentially, applications have gained more importance with the essence of microservices coming to picture. And infrastructure is kind of becoming standardized. So you generally use a particular cloud provider, or you generally use Kubernetes-based infrastructure. So Epsagon essentially came into picture when microservices revolution was kind of complete. And then we realized that, hey, there is metrics and there is logs. But those two are not really effective to troubleshoot applications in a microservices world. So what do we need here?
Usually we use logs only as a, like a last resort. Okay, so let's check the logs and see what's going on there. And we do have metrics, but those metrics might show some current state. For example, if we see something is happening in production, but if we cannot reproduce this because it was a spike, how we can use this data? Like how they use these metrics to investigate? Like we probably need to do something better, right? So we need to kind of maybe find like the ways how we can connect logs and metrics. What do you think?
Exactly. So that's where distributed tracing comes into picture. So essentially, imagine you have an application which consists of thousands of microservices. Now, if a user request comes in, so for example, if a user comes to a website and clicks on a particular application, at most, he or she is touching a subset of those microservices and not all the microservices. So a trace essentially tells you the story behind a particular user action or a request. And that's where the problem might lie in. So for example, if a user is not able to, let's say, put an item into the cart and you have an error there, so distributed tracing helps you to pinpoint where exactly the problem is occurring, which microservices are responsible for that. And essentially, it helps to connect metrics and logs in that way.
So we have a logs, we have metrics, and now we have a traces that allows us kind of like a combine best of the worlds of the historical data that provided by logs, metrics that show some immediate data, and traces that shows things, how they happened in progression in time. Right. So I have a question then. Usually when we talk about metrics, we talk about things that important, how we can choose, or like how people should think about which metrics are, or the traces, or all this information is actionable. Some of the information is actionable, because there are some cases where you see high spikes of CPU, but like, okay, do I need to call my people who's on call right now? Or I see, something where my Kubernetes can handle, for example, auto scaling, just spin up another instance of the application. So in this case, the load will be gradually distributed across things. So can you talk about this? Like, it's not like a technical question. It's more like architectural and more like the cultural question. Like how you would approach, or like what kind of advice you provide to people about which metrics are actionable, impactful for business, and all what we do is essentially serving the business, and we need to make sure that the business continue to run. How you think about this, and how the Epsagon help to think about those things, like business-related metrics and actionable alerts, or actionable items that happened in the systems?
Yeah, that's a great question. So essentially, we have a lot of customers who work in different industries, such as construction or fashion or music. And for them, one of the most important things is revenue.
And it's actually very, very representative in New York. You see a lot of construction, you see fashion and music. That's what you see in New York.
Yeah, exactly. So we get to work with a lot of cool customers. That's why. But yeah, so essentially at a business level, you have a particular list of KPIs defined based on your service level agreements. So SLAs are important, and then you define your KPIs. And the KPIs might be as simple as how much of the time the website is up. So that's a very simple KPI. And then you need to kind of figure out, the engineering team or the CTO needs to figure out, what does it take to keep the website up? So what are the components required in that? And then you can actually define which metrics are important. So for example, if you're using AWS's DynamoDB as your backend database, then you need to figure out how much request time is being taken to fetch data from DynamoDB. So that might be one of your important metrics. So it depends on case-by-case basis, but like business level metrics definitely define engineering metrics, and then the flow goes on at the end.
Can you talk a little bit about some of the most exciting use cases that you work in your work when you're meeting with customers, or your colleagues and meeting with customers, and it's great things that you can talk about. Can you talk a little bit about some of the like cool use cases that you've seen? Maybe collection of some like weird the languages and that application is written. There was have thousands of microservices that some of them written in some of the languages that you never heard.
Yeah, so we had one of the cool things again, as we discussed, was different industries, and they have like so varied use cases, and most of them were doing the transition from being monolithic to being microservices in the recent years. So for them, monoliths were it's a huge mindset shift, right? Moving from monoliths to microservices, and generally people don't really jump directly to serverless functions. They generally take an intermediate step, maybe move to containers and run monolithic applications in containers. It kind of becomes hard to monitor monolithic applications within containers. We can definitely do that, but the ideal case would be running microservices within containers. So one of our customers, for example, did this huge transition, and it required a lot of engineering resources, and they were not seeing the results. So they did not see the transition from monolithic to microservices to their benefit. They were seeing a lot of website downtime. They were seeing a lot of database downtime, and they did not know what was happening essentially. And they were also using Ruby, which is not the most commonly used language in cloud these days. So it was essentially, for us, it was essentially a challenge to figure out what exactly is going on. It was basically trying to figure out two things: the technical challenge of monitoring Ruby applications, as well as helping the customer understand that their transition from monoliths to microservices is an effective one and they should go that route. So we kind of help them observe their entire architecture and their platform. So because of us, their troubleshooting time was kind of reduced by 25%, which was a huge number for them. And they kind of got convinced that microservices is the way to go, and then they stuck with Epsagon as well.
So since we're on this subject, so can you talk a little bit about what it takes to say we have two services, one written in Ruby, another PHP, and maybe third one written in Java? What it takes to install integration with Epsagon? Like, is it require some sort of agent, or those agent needs to be aware about the language that they're running, or it's like some sort of like generic agent that monitors traffic and applies some of the heuristics to extract like information from the thing? So can you talk a little bit about how does it work and what it takes to enable this in your application?
Yeah, sure. So that's the part that you're talking about is basically instrumentation, and it is language specific. So Epsagon supports a bunch of languages such as Node, Go, Java, Python, etc. So right now we have seen a wave of no-code, low-code applications or architecture coming up. And Epsagon definitely supports that kind of motion. So we essentially believe in low-code implementation. So for you to instrument your application, it just requires like 4 or 5 lines of code, and then you're good to go.
So they need to use a library. And recently I started watching some of the videos about like a popular physics with my son. He's only 6, but he's quite interested in quantum physics for some reasons. He's like, when we're driving somewhere or like we're watching, let's watch the video about quantum physics. And in quantum physics, there is a paradox of the observer. So when there's some experiment is happening, usually with even observer, watching something, it actually might affect because the experiment. Usually it happens it doesn't happen on the macro level, it happens on the micro level or nano level, right? When we're talking about particles. And there's like famous experiment when we shooting electrons through the grid, and if we're putting some detector that detects the fly of the electron through this grid, this actually affects the experiment. The same thing is also people talking about the sharding experiment when observer can affect results of if the cat will be dead or alive. So with this regards, so we were instrumenting our code, we're providing some library for our application to measure performance. What's the impact of implementing these things, or like having these libraries in our application that would be impact on our performance, and who's going to be watching for a watcher or something like that?
Yeah, that's a great question. So again, earlier generally people did not care about the agent's CPU or memory consumption because they were using on-premises data centers and stuff like that, so the cost was not much. But now, since you're running almost everything in the cloud, the cost of CPU and memory is definitely high, and Epsagon is kind of cognizant of that. So once we instrument the application, the cost of CPU or memory usage is just about 1 to 2%. So it's not much. Even with the fact that we don't do any sampling, sampling is like the biggest consumption of CPU or memory resources. So we do sampling at our end, and it does not affect the customer's environment. So that's something we were cognizant about when we designed our application.
And what about like a network? Because you either need to like submit all requests or like come with some like smart batching strategies. So the information about and also you don't want to batch too long. So in this case, information would be not super real time and things like that. It's a trade off, I understand. But like, what's you feel? How the users feel about this, and in general, what's your recommendation?
Yeah, so we actually did a very basic cost analysis for the network data that you sent. For example, you need to send metrics data to Epsagon, or you need to send certain trace data to Epsagon. And the cost essentially is in tens or at the most lower hundreds. So it's not very significant. It's minimal to the customer as compared to what observability brings to their entire application.
Yeah, makes sense. So, and since you mentioned the cloud and things that people moving more and more workloads there, and specifically also like application logic, how you approach the question of monitoring this kind of like a serverless, like a function as a service type of applications, Lambda, Google Cloud Functions, and something maybe like a custom implementation. I don't know, like someone might be running some OpenWhisk or something like that.
Yeah, that's a great question again. So Epsagon started with monitoring Lambda applications. So our complete focus when we started back in 2018 was Lambda applications. And all you need to do is essentially just integrate your AWS environment, and that's it. You don't have to worry about anything else. Because we specialize in monitoring Lambda applications, we have like a dashboard and we have a function screen, which essentially tells you if there are any exceptions, what's the cost associated with Lambda functions. So it's very serverless focused. And recently, we also started supporting a lot of Kubernetes and container applications. So it's a combination of both, essentially.
Yeah, that's very exciting. And we continue our show, Kongcast, and this is where we're going to see some of the magic that we were talking about and some of the cool bits that developers can use. Chinmay, take it away.
Thanks, Victor. So, Victor, we talked about what does it take to instrument Epsagon in your applications. So here is a simple code. So essentially, you just need to install Epsagon. And then if you export a few environment variables, that's all you need to do. So essentially, now you have instrumented Epsagon for your Node.js applications. We also support other languages such as Python, Java, Go, Ruby, .NET, etc. So once you have done that, you can start playing around. Great place that I would start would be the service map. This essentially gives you the holistic view of your entire architecture. So this gives you how microservices interact with each other. Here you can essentially see whatever you have designed has been implemented in practice or not. So you can definitely use the service maps in your design phase as well as implementation phase. We have seen customers using the service maps in their implementation phase when they need to do feature development, for example. So how new microservices interact with the older microservices, for example. So here you can see the service maps. There are a bunch of Lambda functions interacting with the Redis database. There's also a DynamoDB table. You can see different arrows here, and they have latencies marked on them. There is also a red colored arrow, which essentially says that there are some errors going on here. So once we click on a particular microservice, a sidebar pops up, which essentially gives you a picture of what the important metrics are with this particular microservice. So the success error ratio, for example, the average duration, and also the API's call breakdown. So once you have that, now you need to know why the error is occurring. So you can directly jump to the traces. And once you're in traces, Epsagon filters out the trace for this particular Lambda function. And then you can jump to any trace that you find interesting. You can compare successful traces with errored out traces, and you can also see the latencies for them. So let's look at this particular error. Once you click on this, this will give you the trace view, and then you can see how the trace is interacting and what errors are happening in this particular trace. So Epsagon's one of the great differentiators is correlating metrics, logs, and traces. And in this complete picture, you can see that a trace, metrics, as well as logs are correlated. Epsagon also does a great job of pointing out why the error is happening. So you can see here that there is something wrong with the coupon discount that's going on. You can click through different microservices and see what information it gives you. Another great distinguishing factor for Epsagon is that it gives you the payload information. So you get whatever payload that has been transferring between microservices, you can get access to it. And you can also see why a particular error is happening. You can also see the timeline view, which will essentially help you to figure out performance and latency issues. And then you can also see the sequence diagram associated with this particular trace. Now, once this is done, this takes care of your application troubleshooting part. The other important environment that you need to monitor might be the Kubernetes environment or the application dashboard environment. So Epsagon gives you a lot of out-of-the-box dashboards. So for example, this is the application overview dashboard. You can see the top 5 applications by errors, and then you can also see the latency and the throughput. You can also jump to the traces associated with this directly from this view, which is a pretty cool feature, I think. And then you can also browse through other dashboards, which essentially can be a Kubernetes dashboard or whatever environment that you're using. So let's look at the Kubernetes overview dashboard. Here, essentially, you can see all the important components of Kubernetes and how are they reacting to your applications running on them. You can see the CPU usage, the memory usage, as well as the nodes. You can obviously correlate them. As you can see here, the CPU usage, the memory usage for nodes, containers, and pods running. You can also use different resources. As I'd mentioned to Victor before, we started off as a serverless monitoring company, and then we moved to Kubernetes and containers as well. So you can monitor essentially ECS, Kubernetes, AppSync, as well as serverless functions. I'll just go through the function screen for this particular demo. In the function screen, you can see the top functions that you're using. When was it last modified, last invocation, the number of errors, the average duration, and the estimated monthly cost as well. You can see all the issues at one place in the issue screen. And that's a really nice thing to have, essentially not digging through different issues. So everything is at one place.
And one thing I personally appreciate is that you have an estimated monthly cost, because it's another very important metric that modern developers need to know. It is how much it goes to run your code. Not only how fast it can go, but how much it actually costs.
Yeah, exactly. I love that feature too. And then finally, you can create alerts on different things such as Lambda, Epsagon metrics, CloudWatch metrics, as well as Epsagon traces. Epsagon also supports metrics data through Prometheus and Grafana, so you can also create alerts based on those metrics as well. So essentially, that's the short 50,000 overview demo of Epsagon.
We'll definitely put the link in the description so you can play around with this. And if you have any questions, we'll also put the contact of Chinmay, so you can reach out to him, since he also fellow developer advocates and helping developers to use this tool. I want to say a huge thank to my guest today. The demo was super exciting. I was very impressed with certain features, especially, like I said, cost, those other things. We discussed this in some of the other podcasts that I was participating, but I think it's one of the metrics that modern developers also need to take into account. Apart from understanding how much it takes to run this cost from perspective of CPU cycles and from perspective of memory, but also how much it costs, when you swipe your credit card. I want to ask one question that I like to ask people is what the book that you recently read, it not necessarily needs to be a technical book or whatever book, and you would recommend other people to read.
Yeah, one of the books that I'm reading right now is called 0 to 1. It essentially is a book about how startups work. And it's by Peter Thiel, who is a well-known investor. And it's about how do you take a startup from 0 to 1. So essentially how you scale a startup, what market should you look for. So it's a pretty interesting read. I kind of agree with most of the concepts there. I don't agree with some of the concepts there. But that's the point of the book, right?
Because Peter Thiel is kind of a controversial person in some circles, but definitely has some ideas around how to build the companies and things like that. Chinmay, last words for our listeners?
Oh, I'm super excited about where the industry is going in terms of microservices and observability. So I really wish all of you can, if you're not really into the microservice world, please hop onto it. And also, please feel free to check out Epsagon. I believe that observability should do the work for you, not the other way around. And with that, I would like to say thank you to all the listeners.
And we will definitely include some links to things that Chinmay mentioned here. As always, my name is Viktor Gamov, and have a nice day.
Thanks to everyone out there for watching. I hope you enjoyed today's episode as much as we enjoyed recording it. Make sure to hit that like button now.
And be sure to subscribe so you don't miss a new episode.
Don't forget to drop us a comment if you have any questions for today's guest or if there's a topic you'd like to see us cover in the future.
And we will see you on the next episode of Kongcast.